We spend our lives looking down at our feet, at our screens, at the paths we've paved. We think of our world as a solid, permanent thing, the center of all that matters. But once in a while, the sun sets, the lights of the city fade, and the curtain of the atmosphere peels back. That is when we see it. A ghostly river of light flowing across the sky, a structure so vast it defies the reach of our numbers, a machine made of 200 billion suns spinning in a silent, perfect rhythm. We call it the Milky Way, our home, our origin, our mystery. But as we peel back the layers of this celestial masterpiece, from its violent heart to its invisible boundaries, one cannot help but feel a deeper resonance. When you look at the intricate clockwork of these billions of stars, the precision of their orbits, and the sheer scale of the beauty before you, does it not make you wonder? Who could have crafted a greatness this absolute? For millennia, we looked up at the Milky Way, and we saw nothing. Not because it was hidden, but because it was too visible. To the ancients, it wasn't a place, it was a texture, a seamless, ghostly ribbon painted across the void. It looked smooth, eternal, untouchable, and that was the great illusion. For centuries, our understanding was held hostage by the limits of our own biology. You see, the human eye is a remarkable tool, but it has a breaking point. It cannot resolve the individual glints of stars packed so tightly together. What we mistook for a celestial cloud was actually the ultimate case of cosmic crowding. We weren't looking at a mist, we were looking at a billion suns blurred together by the sheer scale of the distance. Our ancestors didn't see the architecture of the universe, they saw a limitation of the human lens. And that single misunderstanding shaped every myth, every god, and every map we ever made of the heavens. It's easy to look back and think of ancient astronomy as mere folklore, but that is our mistake. The ancients weren't just dreamers, they were the first master architects of data. Thousands of years before the first computer, Babylonian astronomers were tracking the heartbeat of the cosmos with terrifying precision. They didn't just watch the stars, they mapped their motion down to the arc minute, a measurement so small it's like trying to spot a single grain of sand from a mile away. Across the Silk Roads, Chinese scholars were the keepers of the heavens. They documented guest stars, violent supernovae that appeared out of nowhere. We still use their 1,000-year-old records today to study the wreckage of dead suns. And in the great observatories of the Islamic Golden Age, astronomers did the unthinkable. They challenged the past. They corrected the errors of the Greeks, refining star catalogs and measuring the subtle wobble of our planet's axis with mathematical elegance. But despite all this brilliance, they were hitting a wall made of empty space. They could measure where a star was, they could calculate when it would move, but they couldn't answer the one question that defines our place in the universe: how far? Without the key of distance, the Milky Way remained a flat mystery. It had no depth, no scale. It was a masterpiece without a third dimension. 1610. A small, crude tube of glass changes everything. When Galileo Galilei turned his telescope toward that milky smear in the sky, he expected to see a cosmic mist. Instead, he found something disturbing. The fog vanished. It shattered. Under the magnification of his lens, the cloud dissolved into a granular sea of thousands upon thousands of faint, distant stars. But this discovery didn't bring clarity. It brought a paradox that haunted science for a century. If the Milky Way is just stars, billions of them, then why do they look like this? Why are they trapped in a narrow, glowing ribbon? If the universe is an infinite forest of suns, shouldn't the entire sky be a uniform blaze of light? Why a band? Why a bridge? Why not everywhere? As it turned out, the answer wasn't waiting in a better lens. It was hidden in the math. The mystery of the Milky Way wasn't about what we were looking at. It was about where we were standing. It wasn't a question of technology. It was a masterpiece of geometry. In the late 1700s, William Herschel set out to do the impossible. He wanted to build a three-dimensional map of the entire universe. His method was a feat of pure manual endurance. He called it stargazing. Night after night, Herschel aimed his telescope at over 600 different regions of the sky and simply counted. He assumed that if he saw more stars in one direction, the galaxy extended further that way. The result of his labor was a famous sketch, a jagged, flattened disk that looked like a grindstone. And right there, near the very center, sat our sun. It was a beautiful, symmetrical vision of our place in the cosmos. There was just one problem. It was a total fabrication. Herschel wasn't mapping the galaxy. He was mapping a cage. He didn't know that space isn't empty. It's filled with vast, dark clouds of interstellar dust that soak up light like a sponge. Herschel didn't see the edge of the Milky Way. He saw as far as the fog would let him. He was like a man standing in a thick forest, believing the woods only went as far as the nearest trees. This single, dusty mistake would mislead the greatest minds in astronomy for nearly a century, keeping the true scale of our home a secret.
Space is not empty. It is haunted by a ghost we didn't know how to see: interstellar dust. But this dust doesn't just block light, it lies to us. Think of it as a cosmic filter. This dust is picky. It selectively absorbs blue light, the high-energy short wavelengths, while letting the longer, redder wavelengths slip through. This is the same reason a sunset looks blood red on a hazy day. In the depths of space, this reddening creates a deadly blind spot. Entire star systems, massive clusters, and even the galaxy's majestic spiral arms were effectively erased from our maps. To our ancestors, these regions looked like holes in the sky, cold, empty voids. But they weren't empty. They were just hidden behind a curtain of microscopic soot. For centuries, we were looking at a masterpiece through a muddy lens. It wasn't until we developed supervision, the ability to see in infrared and radio waves, that the curtain finally lifted. When we stopped looking for the light we could see and started looking for the heat we could feel, the Milky Way finally stopped lying to us. The voids exploded with life, and the true gargantuan scale of our home was finally revealed. For centuries, we clung to the comfort of the center. We believed we were the heart of the cosmic story. But in the early 20th century, an astronomer named Harlow Shapley looked away from the dusty horizontal plane of the galaxy and looked up. He focused his gaze on globular clusters, ancient, tightly packed swarms of hundreds of thousands of stars. Think of them as the grand old sentinels of the galaxy. These clusters don't sit in the disk, they orbit the Milky Way in a giant spherical halo, far above the smoke and deception of the dust. Shapley noticed something that changed everything. These clusters weren't centered around us. They were gathered like moths around a distant, invisible flame. As he mapped their positions, a new geometry emerged. They were pointing to a different epicenter, the true gravitational heart of the Milky Way. In a single mathematical stroke, the grindstone model was shattered. The Milky Way finally snapped into focus, and humanity was handed a reality check. We weren't the main attraction. We were moved 26,000 light-years away from importance, demoted to a quiet, unremarkable corner of the galactic suburbs. We weren't the center of the universe. We were just observers on the edge of a much grander stage. When you look at the majestic spiral arms of the Milky Way, your eyes deceive you once again. You see them as solid arms, like the blades of a fan, spinning in unison. But in reality, these arms are not solid at all. They are density waves. Imagine a cosmic traffic jam. A slow-moving truck on a highway causes cars to bunch up behind it. The jam stays in one place, but the cars are constantly moving through it. The stars are the cars. As stars and gas clouds drift through the galaxy, they hit these regions of high density and slow down. In the chaos of the crowd, massive clouds of hydrogen are compressed, collapsing under their own weight to ignite a firestorm of new stars. The spiral arms aren't fixed structures, they are the galaxy's nurseries. Stars aren't born with the arms, they are born because of them. As they age, they eventually break free and continue their lonely journey through the gaps. This is the secret to the Milky Way's eternal beauty. Because these arms are waves of energy, not solid objects, they never tear themselves apart. They are a permanent pattern made of temporary guests, a rhythmic heartbeat that has kept the galaxy alive for 13 billion years. Deep within the spiral arms lie the Milky Way's most secretive chambers, massive molecular clouds. These are the coldest, darkest corners of the galaxy, vast, silent cathedrals of ice and gas, some stretching hundreds of light-years across. Here, the temperature hovers just a few degrees above absolute zero, the absolute floor of physics. It is only in this extreme, motionless cold that gravity can finally win its tug-of-war against pressure. But these clouds need a spark, a shock wave from a dying star, or the squeeze of a density wave ripples through the dark and the collapse begins. The cloud shatters into fragments, each one a potential sun. But here is the secret the textbooks often skip. Most of them fail. For every brilliant star that lights up the night, dozens of others never make it. They are the brown dwarfs, the cosmic stillbirths. They are massive enough to be born, but too small to ignite the fire of fusion. They drift forever through the void as faint, lonely embers that almost lived. For those that do ignite, the birth is anything but peaceful. It is the most violent chapter of a star's life. Newborn protostars are screaming infants of plasma, unleashing savage jets that tear through space for trillions of miles. Their radiation is a hurricane, stripping away the very dust needed to build worlds. Ironically, the same fire that creates a star often incinerates the potential for planets before they even have a chance to form. Life, as we know it, only survives in the rare protected pockets where the chaos has kept at bay. But this destruction serves a higher purpose. When the most massive stars finally reach the end of their lives, they don't just vanish, they explode in a final defiant act called a supernova. In that split second of cosmic fury, they forge the heavy elements, the carbon in your DNA, the oxygen in your lungs, the iron in your blood. You are not just looking at the Milky Way, you are a piece of it, recycled across billions of years. The Milky Way is not a static object, It is a living, breathing recycling engine, scattering the ashes of dead stars to seed the gardens of the next generation.
All of this leads to a chilling reality. The Milky Way is a battlefield, and not every corner is built for survivors. If you travel deep into the galactic center, the sky is a claustrophobic firestorm. Stars are packed so tightly that their gravitational tugs strip planets from their orbits. Supernovae go off like cosmic landmines, bathing everything in lethal radiation. It is a place of magnificent beauty, but it is fundamentally hostile to the slow, delicate dance of biology. But the far edges of the galaxy are no better. Out there, in the outer rim, the ingredients of life are missing. These regions are elementally poor, lacking the heavy metals, carbon, and silicon needed to build rocky worlds. You might find gas giants, but a place to stand? A place for oceans? It's almost impossible. Our sun was born in the Goldilocks zone of the cosmos, the Orion Arm. Think of it as a quiet, upscale suburb. Here, the supernova rate is low, the stellar neighbors keep a respectful distance, ensuring our planetary orbits remain stable for billions of years. We are far enough from the center to avoid the radiation, but close enough to have the heavy elements needed to build Earth. This is the great shift in our perspective. It's no longer enough to look for a habitable planet. We're realizing that for life to exist, you first need a habitable galaxy. We aren't just lucky to have the right distance from our sun. We're lucky to have the right zip code in the universe.
When we look at the Milky Way, we see a powerhouse of creation. But look closer, and you'll find a sobering truth. The galaxy is remarkably inefficient. Most of the gas in these vast spiral arms never becomes a star, it just drifts. Of the small fraction that does ignite, only a tiny percentage will host planets. And of those planets, only a fraction will remain stable long enough for the slow, messy miracle of life to take root. Our existence isn't just a story, it's a statistical anomaly. We are the lucky few who survived a cosmic game of elimination. And if you want to see where that game becomes impossible, look to the heart of the beast, Sagittarius A. The galactic center is, for all intents and purposes, a different universe. Here, stellar density is millions of times higher than in our neighborhood. Stars don't just drift, they scream through space at relativistic speeds, whipped around by a supermassive black hole. Near this gravity well, time itself begins to stretch and dilate. Magnetic fields twist with such violence they could strip the atmosphere off a planet in an instant. This raises a haunting question. Is life an edge case? Are we biased toward the quiet, boring suburbs because the heart of the galaxy is a beautiful, glowing graveyard? But there is one final mystery, the most uncomfortable one of all. Everything we've discussed, the stars, the dust, the black hole, only accounts for a tiny fraction of the Milky Way's mass. The rest? It's invisible. Without dark matter, the Milky Way wouldn't exist. It would simply fly apart, its stars scattered like dust in the wind. This invisible architect sits in a massive halo, reaching far beyond the furthest stars, pulling the strings of every orbit. We don't know what it is. We can't see it, touch it, or trap it, but we know it's there because the galaxy obeys it. We are living in a house built of glass, held together by a ghost we have yet to name.
To our eyes, the Milky Way appears serene, a silent, frozen masterpiece. But that stillness is a lie. Beneath the beauty lies the heart of a predator. Our galaxy is a cannibal. It didn't reach this massive size by accident. It grew through a 13 billion-year campaign of cosmic consumption.
Across the galactic halo, astronomers have discovered stellar streams, long, ghostly ribbons of stars that move in strange, synchronized orbits. These aren't just random clusters, they are the skeletal remains of smaller galaxies. They are the echoes of past meals. Even as we speak, a feast is in progress. The Sagittarius dwarf galaxy, a small, unsuspecting neighbor, is currently being torn limb from limb. The Milky Way's massive tidal forces are shredding it, pulling its stars into long, arcing trails that will eventually be digested into our own spiral arms. In this universe, gravity is the ultimate law, and size is the only protection. The Milky Way doesn't just inhabit space, it claims it. It is a survivor that has built its greatness on the foundations of the fallen. Every star carries a secret. In the world of stellar archaeology, light isn't just something we see, it's something we decode. Think of a star's chemistry as its DNA. By passing starlight through a prism, we reveal a barcode of dark lines, a signature of every element inside that star. We've discovered that metal-poor stars are the elders, ancient relics from a time when the galaxy was young and pure. Metal-rich stars, like our Sun, are the children of chaos, built from the iron and oxygen scattered by generations of dead supernovae. This chemical trail tells us a profound story. Life had to wait for the galaxy to age. In the early Milky Way, planets were an impossibility. There simply wasn't enough stuff, enough carbon, silicon, or iron to build anything solid. For billions of years, the galaxy was a barren wilderness of hydrogen and helium. It took eons of stellar birth and death to cook the universe, enriching the clouds until they were heavy enough to form worlds. We aren't just living in the galaxy, we are living in its maturity. And once we unlocked the secrets of our own home, the rest of the universe fell into place. The Milky Way became our Rosetta Stone. By understanding the physics of our own spiral arms, we realized that the billions of other galaxies across the void weren't alien mysteries, they were echoes of us. They follow the same rules, obey the same gravity, and hide the same ghosts. We didn't explore the Milky Way by traveling through it. We haven't even left our own backyard. Instead, we explored it by learning to see through the lies. We learned how light stretches, how dust hides the truth, and how gravity organizes the beautiful chaos of the deep. And perhaps the greatest discovery we ever made wasn't the billions of stars, the swirling arms, or the black hole at the center. It was the humbling realization of how much we still cannot see. We have mapped the light, but we are still just beginning to understand the shadows. We are a way for the cosmos to know itself, a tiny, improbable lens staring out from the suburbs of a giant, trying to make sense of the invisible. After billions of years and billions of stars, one truth remains. The Milky Way is not finished revealing itself. Every time we launch a new telescope or decode a new signal from the deep, the map changes, the story grows. And neither are we finished asking questions. We began this journey as a species trapped by the limits of our own eyes, mistaking a sea of stars for a simple cloud of mist. But we didn't stop there. We learned to see through the dust, to calculate the invisible, and to read the ancient DNA of the light itself. In the end, the greatest miracle isn't the size of the galaxy. It's the fact that a small, improbable collection of atoms on a tiny blue dot was able to figure it out. Understanding the Milky Way was more than a scientific achievement. It was a rite of passage. It was the moment we stopped looking at the sky as a ceiling and started seeing it as a frontier. It was the moment humanity finally learned how to think
cosmically.